All right, we're starting our new unit with trigonometry today, and we're going to review some right triangle trigonometry that we did, some in Math 2, again in Math 3. And so right triangle trigonometry basically is talking about sine, cosine, and tangent. Abbreviation for sine is sine, and we say sine of theta. Cosine is cosine of theta. And tangent is tangent of theta. This is called theta. It is the variable for angles. Now, when we're talking about the fraction that goes along with that, basically if we draw a right triangle and we make a theta, the sine is the opposite over the hypotenuse. So the opposite is always the side you can draw an angle out to. So this is your opposite side. The angle opposite the right angle is always your hypotenuse. The cosine is adjacent over hypotenuse. And adjacent means next to. So next to theta here would be the adjacent side. And then tangent would be opposite over adjacent. And you'll often see me write these as O over H, A over H, or O over A. Okay. The SOHCAHTOA saying, probably you've heard, some old hippie caught another hippie tripping on acid. Some old hippie caught another hippie tripping on acid. Now, why does that saying help us? Because what it says is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, which is what this is right here. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. There are a couple of things that you could be looking for in a right triangle. You can be finding the side or the angle, or you could just be finding the value of the trig function. When you're finding the side, you want to identify all the known parts or the given parts. You want to figure out which trig ratio to use, set up an equation, and then solve for the variable. And in this, we're just going to use the regular trig function. When we're identifying an angle, we do the same thing. We identify the known parts, we figure out which trig ratio to use, we set up an equation, and we solve for the variable. But when we're solving for the variable with an angle, you'll notice a couple of things here. We use the second trig button if we're using our calculator, or the inverse trig, which is this trig to the -1. So you'll see sine to the -1, cosine to the -1, or tangent to the -1. Okay, so let's look at some of these. So if you're finding cosine of theta, so first always identify the sides. So this is the opposite side. There's the right angle, so this makes this the hypotenuse. This makes this the adjacent. So the cosine is adjacent over hypotenuse. So the cosine of this would be 8 over 17. So here's theta. So this is the opposite side. Here's the right angle. So here's the hypotenuse. That makes this the adjacent side. So tangent is opposite over adjacent. And so we say that the answer is 16 over 30. And you should reduce that. So you can put that in your calculator and reduce it to 8 over 15. So here is the opposite side. Here is the hypotenuse. That makes this the adjacent. Cotangent is, we didn't put those on here. I guess I should do that, huh? So let's go back up here. I'm going to have to redo this worksheet. So cotangent is 1 over tangent. So that's going to be adjacent over opposite. Secant is 1 over cosine. So that'd be hypotenuse over adjacent. And cosecant is 1 over sine. So that is opposite, hypotenuse over opposite. Okay, so back down here, cotangent is adjacent over opposite. And so we get 3 over 4. So here's the answers here. The sine of theta, well, here's the opposite. Here's the hypotenuse. Here's the adjacent. So sine is opposite over hypotenuse, which would be 6 over 10, which reduces to 3 over 5. Secant is hypotenuse over, what did we say? Let's look at it, because those don't go along with our SOHCAHTOA. So secant is hypotenuse over adjacent. So here is the opposite. Here is the hypotenuse. Here is the adjacent. So this is 15 over 9. Again, we would reduce. So that would make 5 over 3. And cosecant is hypotenuse over opposite. So here, make sure you draw a straight line or you'll get the wrong side, is the opposite. Here's the hypotenuse. And here's the adjacent. One other thing to notice is the hypotenuse will always be the largest side. Okay, just a note. All right, so let's look at solving some sides now. So again, we need to label the parts. We could label this side, which would be opposite, but we don't have this side, so I don't want to list that. So I'm going to list this as the hypotenuse. Okay. And this, I just stopped writing. I don't know what happened. And this is the adjacent. And so you ask yourself, here's SOHCAHTOA. And I'm going to write it this way. Maybe this will help some of you. Okay. So what trig function has adjacent and hypotenuse? Well, that's this function. So that's the cosine. So we say the cosine of the angle equals the adjacent side divided by the hypotenuse. And then we had a note here that said there's only 3 ways to solve an equation. If x is on top, Come on. So if x is on top, we multiply by the bottom. If x is on bottom, we switch x in the trig function. And if x has an angle, we do second trig. Okay? So our equation has x on top, so we're going to multiply by the bottom on both sides. So we're going to put this in our trig function in our calculators. So we're going to go right over here to Desmos, and we're going to put in 9 and make sure it's in functions under trig. See, it says cosine of 15. Let me make sure I'm in the right thing. The other thing you need to make sure is if you click this wrench, change it to degrees, okay? So it needs to make sure that your mode is always in degrees. So the answer to the question is 8.69, okay? So x equals 8.69. All right, so mode equals degrees. Use the wrench. All right, so here we have the opposite side. Here we have the hypotenuse. So opposite and hypotenuse is sine. So the sine of 50 equals 9 over x. Well, when x is in the denominator, these two things switch places, okay? So what happens is we get x equals 9 over the sine of 50. And so we put this in our calculators, and we get, oh, I forgot what it is that quick. 9 over the sine of 50. So 9 divided by, ooh, too many nines. The sine of 50. And so we get 11.75 as our answer. All right, so this would be the opposite side, but we don't have that. This is the hypotenuse, so that makes this the adjacent. So again, we have cosine. So we have the cosine of the angle equals the adjacent over the hypotenuse. So again, these are switching places. So we get x equals 10, the cosine of 51. So x equals 10, the cosine of 51. Oh, that's not right because it should be divided by. Ooh. Let me get rid of this. There we go. So 15.89. And remember, the hypotenuse should always be the larger side. So if you get something that's smaller than 10, you know you've done something wrong. All right. I'm going to change colors here so we have something a little different here on the screen. Maybe that'll help with this different things here. So here we have, maybe not. Here we have the opposite side. Here we have the hypotenuse, so that makes this the adjacent side. So opposite and adjacent is tangent. So the tangent of 55 degrees equals x over 20. When x is in the numerator, we multiply by the denominator. So we get 20 tangent 55 to put in our calculators. So 20 tangent 55. So 20, the tangent of 55 is 28.56. This is the opposite. This is the hypotenuse. That makes this the adjacent. So again, we have tangent. The tangent of 72 degrees equals 80 over x. So these are going to flip places. So we get x equals 80 divided by the tangent of 72. So 80 divided by the tangent of 72. So 25.99. And the last one here, looking for a side, here's the opposite. Here's the hypotenuse. So that gives me the sine of 24 equals x over 283. Again, we're going to multiply by the denominator because x is in the numerator. So we get 283 times the sine of 24. 283 times the sine of 24. So 115.11. Now, you do this same concept when you are solving for angles, except what happens here, here's the opposite. Here would be the hypotenuse. Here's the adjacent. So we know it's the tangent of, well, we don't know what the angle is. Now our angle is just theta. And so the opposite is 17.2 over 9. Well, our variable is right here. So in order to get rid of this tangent, we can't divide by tangent. The equivalent of dividing by tangent is doing the inverse tangent. And so that's why we get the inverse tangent of 17.2 over 9. And so this is what we would put in our calculator. You had to make sure that you use this tangent to the -1. And so that has its own button. So we would say functions, and you'll see right here, it says tangent to the -1, not tangent, but tangent to the -1. And then we would use the 17.2 divided by 9. So then we would say 17.2 divided by 9. And what happens now is this is giving us the angle of 62.38. Okay? So theta is now 62.38 degrees. So same concept here. This is the opposite. We don't have that. This is the hypotenuse. That makes this the adjacent. So the cosine of theta, because we don't know what our angle is 7 over 23. So to get theta by itself, we do the inverse cosine of 7 over 23. So back over here, the inverse cosine of 7 over 23 is 72.28. So theta equals 72.28 degrees. And the last one here, this is the opposite, and this is the hypotenuse, which means that's cosine. So the cosine of theta, that's our angle, because we always do an angle here, is 200 over 400. And so theta equals the inverse cosine of 200 over 400. And so we say, I did not write that right. That should be sine. Sorry. Just realized it. Sine. Because it's opposite over hypotenuse. Sorry about that. Sine of, so inverse sine of 200 divided by 400. And so then you get 30 degrees. So theta is 30 degrees. So your worksheet is going to ask you to find just some basic functions by looking at the sides. And always identify the side first. Then it's going to ask you to find some sides, and then it's going to ask you to find some angles. So you'll need to do that first for this week.